So here's why we would actually use VLANs. So in this scenario, what I have is I have this client domain over here, this client set of computers, and they're hooked up to one switch and they're part of one broadcast domain. One of the switch ports goes over to a router interface so that we can talk from these workstations here out to the internet or out to our web servers in our local organization. All right, we have a second broadcast domain here, and that's hooked up to a second switch, which is hooked up to a second router interface, and that hosts our web servers. So this serves as kind of like a server farm, or sometimes if it's a web server where we need internet access, we might call this a demilitarized zone. And when we actually configure access control lists, we will configure a DMZ, or a demilitarized zone. It's basically an area of specialized security in our network. We're not too concerned about that right now. We're stuck with VLANs here, so we're just looking at the broadcast domain, which, if you remember, is a layer 2 frame is used to create a broadcast. So my server broadcast domain over here on the right, I've surrounded that with a dashed line that also hooks up to my router. These broadcast domains, if you remember right, are on two separate layer 3 networks, or two separate IP networks. Okay, so each of these is on its own IP network. Broadcast messages from the client broadcast domain cannot propagate to the server broadcast domain. And the reason for that is we put a router in the middle. And if you remember what routers do to frames, the router throws the frame away, right? It throws a frame header away, looks at the destination IP address of the packet, and then forwards it on. So the routers throw the frame away, so the broadcast message cannot possibly traverse from the client broadcast domain over here to the server broadcast domain. So we can actually set this up with one single switch. And here's how we do it. We have our client broadcast domain. We have our server broadcast domain. They're each hooked up to separate interfaces on our router, and yet we only have it connected to one switch. So how do we keep the broadcast messages from the client broadcast domain from reaching the server broadcast domain? And this is exactly where we use VLANs. So what we do then is we assign VLAN 10 to the switch ports that are connected to our clients, and we assign VLAN 20 to our switch port that is connected to our servers. And now what we do is we've actually set this up so that a broadcast message that occurs on VLAN 10 cannot propagate into VLAN 20. The reason for that is there's a rule on the switch written into the software on the switch that says do not allow traffic to propagate from one VLAN to another VLAN. If we want traffic to propagate from VLAN 10, which is on one IP network, to VLAN 20, which is on a different IP network, we have to go through the router. So if I want to access the website on web server 1, I have to send the message from my workstation to the router. The router then has to route it to the other VLAN, VLAN 20, which then goes to the web server and then back again. But in order to get from VLAN 10 to VLAN 20, we have to go through a router, because this setup is exactly the same as the setup we had here when we were using two switches to do the same thing. When we use two switches, we don't have to worry about VLANs. Once we add a switch that's VLAN capable, we can then use a single switch to have multiple broadcast domains connected to it. You might be asking yourself, why would we just buy one switch and use VLANs versus buying two switch and not using VLANs? Well, switches are expensive. Cisco switches are especially expensive. A 24 port 3750 switch might cost you between $5,000 and $8,000 or more, depending if you needed other software on it. So if we only have this network with 1, 2, 3, 4, 5 devices and a router in the middle, what we really need here is we need 1, 2, 3, 4, 5, 6, 7 switch ports to accommodate this network. Well, I could buy two 24 port switches at $5,000 to $8,000 a piece, or I could buy one switch at $5,000 to $8,000. Right? So does this mean all Cisco switches cost $5,000 to $8,000? Absolutely not. There's massive varieties of prices out there, but a high-end Cisco switch could cost you that much money for 24 ports. So we want to make this as efficient as possible. We can do that by using VLANs here. Another implementation of this is going to be for security reasons, which is a bit beyond the introductory version of VLANs. But ultimately, know that VLANs are a broadcast domain, and VLANs can be configured on one single switch to allow multiple broadcast domains on one switch.